Hello. In this video, I'll run through examples 2.23 and 2.24 from the text. So this is to help understand how to take the union and intersection of many sets at once. So while union and intersection are only defined for two sets, it's a binary operation. Because they have the associative law, it doesn't matter how I group them, and it's okay to consider the union of many sets or the intersection of many sets. So what A union B union C is really looking for here, this is the collection of all elements that are in at least one of A, B, or C. Similar for intersection. A intersect B intersect C is the collection of all elements that are in each of A, B, and C. So to be in the intersection, you have to be in all three of the sets. To be in the union, you just have to be in at least one of the sets. Again, this is how to think of union and intersection. So for A union B union C, take the union of all three of them. Again, I'm going to collect all of them that are in at least one of these. So I have 1, 3, and 4. Those are the ones in A. I also need to include all the ones that are in B. So 3, 4, and 6. Now I've already got 3, 3, and 4 in here, so I don't need to include those again, but I'll put 6 in there because that was also in B. Then I also need to include 2, 3, and 5. Now I haven't hit 2 yet, so 2's in there. 3 we've already accounted for, but 5 is a new one, and so that gets added as well. So each of these elements are in at least one of A, B, or C. Hence, they're all in the union. For the intersection, again, I want all of the elements that are in every single one of these, right? I only include elements that are common to all three. So let's take a look. I have 1 is in A, but 1's not in B, so 1's not in the intersection. 3 is in A. 3 is also in B. We're off to a good start there. And 3 is in C. So notice that 3 appears in each of the sets. Hence, 3 is in the intersection. Let's see, are there any more that appear in all three sets? Well, 4 is in A, 4 is in B, that's off to a good start, but 4 is not in C. So 4 is not in every set, and so it's not included, and that runs through all the possibilities, right? We run through all the elements of A, so any other element, for example, 5 wouldn't be in A, so that's not included. So A intersect B, intersect C would just be the set containing 3. So that's the idea. Common has to be common to all three sets, just has to be in at least one of the sets. That's the idea. So that's just three sets, union and intersection of 3, but we can take the union and intersection of any number of sets. And in fact, our definition extends even to an infinite union of sets, but I'm not going to ask you to do that. We can do finite sets though. So for this one, we define 10 different sets. So for each I between 1 and 10, we define the set A sub I to be I and I plus 1. So maybe it's helpful to first identify what these sets are. So A1, see, my I is between 1 and 10, so I'll start with 1, would be the set 1 and I plus 1, so 1 plus 1, 2 would be the set 1, 2. I guess let me go vertically here. A2 would be the set I, 2, and 2 plus 1, 3. And so on. So A3 would be 3, 4. A4 would be 4, 5. So on and so on. Now here my indexing set is I between 1 and 10. So the last one I'll consider is A10, which would be 10 and 11. So these are all the sets here, and now I need to think about, in order to compute the union of all of them, so the notation is for union of all the sets A sub I for I between 1 and 10. So this is the collection, again, it's a collection of all elements that are in at least one of the A sub i's, so at least one of these sets. So 1 and 2 is in there, 3 is in there because it's an A sub 2 and A sub 3, 4 is in there because it's an A sub 3. So you should be able to see, hopefully piece it together, that we'll have every single element between every single integer between 1 and 11. Every one of those integers appears in at least one of these sets. So 10 up to 11 would be the union in this case. Intersection, I equals 1 to 10. I want to collect all the elements that are in every set. So I can only put things here that are in each one of these. So notice that A1 intersect A2, right? It would need to be an A1 intersect A2, as well as others. Just 2 is common to A1 intersect A2. But then 2 is not an A3, and so I wouldn't be able to include 2 in this. 1 is only an A sub 1, and it doesn't appear in any other set. So 1 can't be in the intersection of all 10 of these sets. So maybe you're starting to see, right, 3 is in A sub 2 and A sub 3, but it's not in any of the other sets. Hence, it's not in the intersection of all of them. So it appears there are no elements that are in every set in this collection. So the intersection of all the A sub I is the empty set, saying there are no elements that are in each of the A sub i's. So that's union intersection of many sets. All right, that's it for this video.